All right, next up, we have Erik Michelson. He is currently a Deputy Director for Anne Arundel County's Department of Public Works. He heads its Bureau of Watershed Protection and Restoration. He works to facilitate the recovery of the Chesapeake Bay and its tributaries through supporting robust restoration projects and rigorous scientific monitoring efforts, bolstered by diverse stakeholder partnerships. Erik has an extensive background as a project manager for an environmental consultant, and then as the executive director for a nonprofit, the Arundel Rivers Federation, formerly the South River Federation, and working for Anne Arundel County since 2014 as the county builds up the environmental assessments, restoration, and implementation and ecological evaluation to support the county's clean water obligations under the Municipal Separate Stormwater System, MS4 permit, and the Chesapeake Bay Total Maximum Daily Load, TMDL.
Thanks for the introduction. And in some respects, I think this presentation or parts of this presentation have a particular relevance to the Chesapeake Bay region, but I'm hopeful that the sort of thoughts that are discussed here and maybe some of the lessons taken away from this can be applied more broadly. But I want to start with a little bit of context in terms of why we decided to pursue this this approach or this look at this question, and why it's relevant, particularly to a Department of Public Works in my case. So a couple of years back, well, I'm sorry, let me take another step back. So the work that you saw from Laura and Joe and Mike, that's all the kind of conventional restoration projects that our Bureau puts into the ground for our regulatory compliance, both with our MS4 stormwater permit, which is a stormwater permit that most of the large jurisdictions throughout the country have, as well as the Chesapeake Bay TMDL, which you heard Scott talk about earlier today. So we've got these regulatory requirements where we've got to treat essentially untreated stormwater from the developed landscape, as well as reduce nutrients and sediment to our local waterways into the Chesapeake Bay. And so we've been doing that through a variety of practices, a ton of stream restoration. The project that you saw that Mike presented is actually one of our projects that we funded. The project that Joe and Laura showed was for the State Highway Administration, achieving some of their goals along the same lines. And so we've been fortunate in the Bay region to have the Chesapeake Bay program, which is a branch of the US EPA, develop model efficiencies for a variety of practices. It's basically allowed us, the regulated entities, essentially to implement projects on a broad scale with a baseline understanding in terms of what are the reductions that we're going to be given as a result of implementing these projects. So we're not having to monitor every project as it goes in on a project by project basis. It allows that work to go in on a broad scale and be accomplished, and us to have some kind of certainty in terms of the reductions that we're going to get for it. And so having that I'd say sort of currency or that level set of the BMP efficiencies has been very, very effective in terms of doing a lot of implementation and getting jurisdictions to be able to pursue that. Conceptually, and I think intuitively, the idea that beaver ponds provide some kind of water quality treatment has been something that's resonated with me for a long time. And so this presentation and this discussion and hopefully the pursuit of this notion really is aimed at trying to figure out, are there ways that we can recognize the water quality values of these facilities? And I think Bob Boucher did a great job in terms of looking at it from a flood attenuation perspective in his presentation. But so that we can look at them as features that not only we want to preserve on the landscape, and maybe we'll spend some money to preserve, but that we can also do things to incentivize in terms of finding ways to expand their presence on the landscape. The other piece I just want to mention is, again, being in a Department of Public Works, this question and sort of this being able to assign to a certain extent a dollar value to this kind of work is important, because our Bureau of Utilities, who's got sewer infrastructure in these stream valleys, oftentimes has conflicts with beaver presence. Our Highways Bureau, who has road crossings that come over these stream systems, oftentimes has conflicts with beaver presence. And so being able to make a financial calculation or being able to assign a financial value to the value of these beaver ponds allows us to make a more informed decision in terms of management going forward. So I think that's just an important context for this, and hopefully there'll be time for questions at the end of the presentation as well. So the conceptual model of beaver ponds, I mean, this is the choir I'm talking to. So I don't think I really have to do a whole lot of background here, but we obviously recognize that the ponds themselves are depositional areas for sediment. They're wetland creation areas where we've got nutrient processing, we've got carbon storage, we've got a whole host of other benefits that we, I think, can intuitively understand are providing water quality benefits. But there's also a science that's fairly robust at this point backing that up. And in Anne Arundel County, we're fortunate to actually have sort of one of the gold standard papers on the benefits, the water quality benefits of beaver ponds that was done locally. Hillary, in her presentation, mentioned the Smithsonian Environmental Research Center. It's based in Edgewater, not far from the area where Mike's restoration project was. It's been in place since the early 1970s, and they have had monitoring stations on a variety of streams running throughout the site since the early 1970s. So we've got an incredible backlog of data that's been captured from those sites. As it so happens, in the 1980s, we had sort of a natural experiment occur where one of those systems that had been monitored for a decade prior had a beaver dam constructed on it. So we had a sort of an experimental system that had been beaver impounded, and we had the control system right next to it that was not beaver impounded. Being that this is a campus essentially of researchers, of course, folks really took to that as an opportunity to look at what were the impacts. And they did sample this area from 84 through 96, both in the Beaver and control watershed. So this is, like I say, really a gold standard project where we have that before, after, and control impact study design. It's not oftentimes that you've got the length of data that you've got here, as well as the sort of natural experiment that occurs. In terms of that paper, what they found was that there was seasonal variation in terms of trapping and export. So here, what you'll see, it's the two left-hand bars in each of these figures are the beaver systems before and after, and then the control systems before and after on the right-hand side. So here in the summertime, you can see that actually both the beaver and the control systems are demonstrating reductions in nitrogen, which is the blue bar, phosphorus, which is the pink bar, and then sediment. But there's quite a bit of inter-seasonal variability in terms of what you see there, and that the retention rates were the greatest in the summer and winter. And there was some export in the spring, probably as a result of high precipitation. A lot of this is tied to precipitation events. But in the aggregate, what they found was that there was a pretty dramatic reduction in the beaver impounded system over the course of those annual periods in terms of all three factors. So you can see the reduction from before to after in terms of nitrogen, phosphorus, sediment. And they saw the reverse effect in terms of the control, which was actually a little bit of an increase in nitrogen, phosphorus, and sediment. And that's probably due to, basically to interannual variability or maybe increases in precipitation over the period. But what they were able to derive from that was that on an annual basis, they were seeing reductions of about 20% of nitrogen, 37% of phosphorus, and about 63% of sediment trapping in that beaver impounded watershed. So that big beaver pond at the Smithsonian Environmental Research Center was showing significant reductions on a fairly large scale watershed in this case. And so what we did, again, was in terms of the best management practices and the guidance manuals that the Chesapeake Bay program has, really the best way to seek adoption of a new practice or a sort of a novel opportunity is to figure out, is there a way to piggyback that on an existing practice? And so what we did was, and all of this analytic work was done by Josh Thompson, within my group who is just a whiz and incredibly bright in terms of being able to pull all this data together. But so what he did was he went into the International Stormwater Database, the link is down here at the bottom of the presentation, and looked at data from wet retention ponds and wetland basins for constructed stormwater practices, essentially in this database. And he pulled that data, and what you can see here is essentially, and I'll get to the cut to the chase at the end here in a second, but that basically in the cases where you've got the black dots, those were net retainers of in this case, phosphorus and TSS. In some of these instances, there were actually some export from those facilities. But in the aggregate, in terms of these constructed engineered stormwater practices that we think are somewhat analogous to Beaver impoundments, what he was finding was reductions of about 11% for nitrogen, about 30% for phosphorus, and 62% for TSS. So you can see they're in the same ballpark, even though the data from the CERC presentation is actually a little bit more generous in terms of the reductions. But there's probably a case to be made that this is a reasonable analog in terms of what you're seeing with those reductions. And so what we did was we went through the county and as has been described earlier, I mean, we're a suburban county of about 500, 600,000 people in the middle of Maryland. We've got a lot of suburban development, a lot of areas where Beaver have just over the last 10 or 15 years moved into our stream systems. I'll talk a little bit more about that at the end of the presentation as well. But we wanted to go through some sort of thought examples of what would we be looking at in terms of reductions if we were to take account of these beaver ponds. So this particular site, the North Cypress branch, is actually a stream restoration project that the county built 7 or 8 years ago. The Beaver set up shop at the top of this stream restoration project. They basically created their dam at the top of the project. And as a result of that dam, which is about 3 feet in height, they've raised the elevation of this pond considerably, creating additional storage above the storage that was designed as part of the restoration project. We've actually worked with, in this case, Ecotone, to put in a pond lever to keep the water down a little bit, because as you can see, there's like a senior citizen apartment complex here to the side. And so as the water gets too high, we begin to get lots of phone calls about concerned people with regards to this water surface elevation. So we did put a pond leveler in, but to keep the pond at that elevation. And so what we've done, and there's a lot of numbers here, so I hope your eyes won't glaze over, but what we're actually going to do is put together a white paper explaining the methodology for what we've done here that will be available to folks who are interested in trying to run their own examples through this. Essentially, though, what we've done is we've estimated the pond volume based on the level of the pond and the perimeter of the pond. And we've taken, just to be conservative, about 60% of that volume, and then looked at if that were a wet extended detention pond that we had installed in that watershed, what would the reductions be that we would get? In this case, this is about a 307-acre drainage area. That volume, which is almost 3 acre-feet of water storage in that beaver pond, gives us what is about 22% of the treatment volume. In Maryland, we're essentially aiming for treating the 1-inch rain event as part of a water quality treatment methodology. And so that doesn't give us all of that 1 inch. It gives us about a quarter of that 1 inch. And so our credited efficiencies are a little bit less than we might otherwise get. But what this translates to in terms of our metric of concern, our MS4 permit is measured in impervious acres treated, which is really a proxy for nutrient and sediment reductions. It gives us about 33 acres of impervious treatment. And I think this is sort of the takeaway, and this will be throughout the rest of the examples as well, is that in our language, in terms of permit compliance, for us to treat, and I guess it was Joe or somebody had presented a slide of a bioretention area. For us it was Scott, actually, I'm sorry. For us to implement a project like that, we're looking at about $50,000 per acre treated in terms of an engineered project into the ground. So if we were to convert that restoration credit multiply it by that acre treated, that's about a $1.7 million value to the county in terms of that beaver pond that we're not getting any credit for. That's not even being recognized in any kind of modeling example. But that amount of storage, that amount of treatment that we're getting could have a real substantial value to us. Now, there are some adaptive management costs in this particular case on our side. You saw the installation of the pond leveler at the top of the pond. We're actually in the process of installing another pond leveler because the beaver have impounded this entire system almost down to tidewater at this point. And we've also had to do some tree removal where the beaver have gotten a little bit overly aggressive downstream. This is actually the downstream of that area. I've got some drone photographs. You can see basically 3,000 linear feet of this system. And I agree with Scott too. We should be counting restoration in acres, not linear feet, but 3,000 linear feet of this system, which was restored several years ago, is basically underwater now as a result of the beaver ponds. This is more beaver ponds, about 4 or 5 sequential beaver ponds. There's a big one here. This is where we're going to put the pond leveler, and then tidewater is right down here off the image. So there are some adaptive management costs, but if you look at those adaptive management costs in the context of what the potential value from a water quality perspective is, it really is inconsequential, but it does make the case for why it's so important for us to begin to figure out a way to put a number on these figures. This is actually that the dam at the bottom of the feature. And as I think Scott had said, this was not a natural channel design project that went underwater. It was a floodplain reconnection project, but all of that work, all that stone is essentially under 3 feet of water here as a result. And that was a multi-million-dollar project too. I've got a couple more examples that I'll go through. Same principle here. This is actually a site, again, where beaver, it's not a restoration site, although it's above a restoration site. They've built a dam on Wolf Pit Branch, which is on Cattail Creek, which is a tributary to the Magothy River. Again, here the dam height's about 1.5 feet. This is a photograph of that area. It's a really large natural area where the pond is not causing any issues. It's above the road, so it's not causing any flooding concerns, but just a really nice environmental feature. Again, same exercise. Take that dam height, look at the drainage area, which is massive in this case, about a 1,400, for us, massive, a 1,400 acre drainage area. We get actually a very small fraction of that treatment volume that we're looking for here, about 6%. But because the drainage area is so large, that still translates into about 20 acres of impervious treatment for us here at a value of about $1.2 million. And this is, again, a case where we actually haven't had to intervene in terms of an adaptive management set of interventions. And so there's not really been any expense on the county's part in this particular instance. This is another one that's interesting, like so many of our restoration projects, and I'll show some of those pictures at the end of the presentation. We come in here, do the work. Our grade control structures end up being a perfect platform for the beaver to set up the shop on in terms of their dams. In this case, we didn't actually have the ortho imagery because the pond was so new that we didn't have it showing up yet. But we used a little bit reduced to 50% observation of the dam elevation and the perimeter of the facility. So this is downstream of the pond. This is the dam itself. This is the area impounded by the pond. This is an interesting story too, because again, the wonders of doing beaver management in a suburban area. You can see the well manicured landscaping right to the edge of here has proven to be a little bit of an interesting set of circumstances as well. In any case, dam height's about 4 feet, so we used 50% of that, about 125 acre drainage area. In this case, we get again about 1/4 of the treatment volume. It's a little bit smaller credit, 8 acres. About about a $400,000 value. And again, this is another case where we did install a pond leveler. So there's been some cost to the county, about $8,000 with an expectation of about $1,000 of annual maintenance. So again, just even in balance, there's a tremendous value here from an economic perspective, in addition to all of the kind of habitat, environmental benefits that we can recognize as well. I think from with a BM, in proposing that this be a BMP or recognized as such. There's obviously questions about verification. For conventional stormwater practices, the state requires triennial inspection of those facilities to make sure that they're operating properly. Here, there are a variety of tools. There's the orthoimagery that the county collects on a 1 or 2 year basis. There's also obviously opportunities for visual inspection of these facilities that would probably need to be done on more than a triennial basis, given the sort of fact that these can be ephemeral in this kind of environment. So the future work in terms of what we're looking at is, starting up discussions with MDE and the regulatory agencies about considering, the evaluation along these lines. And maybe there's a good opportunity to work with the Bay Foundation and Hillary on proposing something along those lines. We will probably be working to better refine the numbers by doing some of our own research in terms of pond geometry and the nutrient and sediment trapping of these features. And then some of the other research that's in the field, again, shows that as these basin sizes increase, and this is in the case of phosphorus, out west, you're likely to see additional phosphorus trapping. And we expect that probably those relationships are actually likely to be even stronger in an urban or suburban setting where you've actually probably got more nutrient-rich waterways as opposed to, essentially wildland areas. So in summary, again, as we set out from the outset, we do believe these beaver ponds are analogous to some of the conventional stormwater practices that we're building, engineering, and installing. Obviously, beaver, some of the engineering and flooding concerns that come along with beaver need to be addressed, but there are a lot of tools that we've now got to adaptively manage these pond elevations if they need to be done. And that we think that beaver ponds can reasonably be credited using a shorthand like this to get this ball rolling on this conversation. I mentioned about verification. Another thought is that perhaps beaver BMPs could be an annual practice, and so that there would need to be some kind of annual recognition that that feature is still in place and that the regulatory agency could still take credit for it. And then we're doing much of the same kind of thing that was being shown in Wisconsin and has been done in the Rocky Mountain West in terms of trying to figure out where is suitable beaver habitat within the county and what might that look like in terms of either acquisition of floodplain areas or trying to find spots where beaver could reasonably move in without expecting lots of conflicts with humans. The rest of my presentation is really just a series of pretty slides of areas where beaver have moved into our restoration projects. This is our wetland and stream restoration project at the preserve at Eisenhower Golf Course, just outside Annapolis. Project went in, beaver set up their pond at the bottom of that structure, impounded water into our feature. It's great. It's exactly what we're looking for. As long as the golf course is happy, we're happy. Cowhide Branch, this is another project in Annapolis, just outside downtown Annapolis, downstream of where the hospital is, if you know that area. You can see the beaver have set up shop here. This is several acres, probably 5 acres of wetland above. We did this restoration project several years ago as part of a fish passage effort. And so they very reliably moved in. Will, Eleanor, this is a project that's now about 15 years old. Over the years, beaver have moved in and out of that system, thanks, over time. And again, sort of getting the neighbors comfortable with them being there has been important. And we've had to do some adaptive management actually to this project as a result of beaver impacts. I would say that in some cases, in this particular project, beaver have put more strain on the original project than probably would have otherwise been there, which has been a lesson learned in terms of how we develop and design projects going forward. And then finally, Towser's Branch. This is a site where there's probably about a 2 square mile drainage area coming through here. We had put a in-stream grade control in the main stem of this system. And then within a few years, beaver actually dammed this valley, which is probably about 300 or 400 feet wide, both on that structure, and then dammed it downstream. And that dam has unfortunately come out since then. But we are finding very, very frequently that our restoration projects are being colonized by beaver shortly after restoration. And I want to give a special thanks, like I say, to Josh Thompson and Brenda Morgan within my group who did a lot of the legwork in terms of pulling this together. So thank you very much. And I'm answer a few questions if I've still got a few minutes.
You said you used, it looked like 50% or 60% of the dam height on a lot of the calculations. Was that because of variability of the water level or seasonality or something of that?
It was really to be just conservative in our estimation. I mean, I think the last thing that we want to be accused of is sort of like blowing up the numbers here. So wherever we could, both in terms of the efficiencies and then in terms of the storage volumes, at least for the purposes of this exercise, we wanted to err on the side of being conservative. I think, a case could be made that if you want to get your survey crew out there and document the actual elevations, and that's a true 3 feet at this volume, I think that that's a reasonable thing to do just for the purposes of this exercise. Like I say, we wanted to err a little bit on the side of being conservative.
Hi there, I'm Elisa with Beavers Northwest. So I've talked with a few stormwater professionals who are starting to see beavers move into retention ponds in Washington. And I'm curious from your perspective, if you think there is tolerance for that. I see a lot of very nervous engineers who think that these beavers are kind of messing with that capacity, but I hear a lot from you that we're kind of mimicking a beaver system, which is the way I've thought about it in my head. So curious about your thoughts on capacity for beavers in some of these engineered stormwater systems.
Yeah, so in terms of stream restoration projects, at this point, we're very supportive, and we're taking active steps, as you've seen with some of these pond levelers and that sort of thing, and tree removal to try to have coexistence. And really, when I give my restoration presentations at this point, what I say is, we're starting to design restoration projects with the assumption that it's inevitable that beaver will move into them. We want the beaver to move in. We want our systems to be stable once they move in, because we know they will move in. I think in ponds and more highly engineered features, it gets to be a little bit more complicated question because, again, of you may have sort of like very precisely notched weirs in terms of low flow volumes. You obviously don't want a pond, the low flow being jammed and then having water go over an emergency spillway or something like that because the outlet has been completely clogged up. And so I think we're generally more comfortable with them in sort of these quasi-natural systems than we are in these more highly engineered systems. But I would say it's a case-by-case basis. If a stormwater wetland, for instance, goes underwater and they're not doing anything with the outlet structures, I don't know that we'd necessarily have a problem keeping them there. We'd certainly keep an eye on how that situation developed. But I think it has to do with sort of when you've got these engineered outflow locations, you just want to be careful that you're not putting water in places where it really shouldn't go when that system is at full capacity.
Hi, thank you. I'm curious about land ownership. You mentioned acquisition versus leases. Do you feel like there would be the appetite when considering this for reimbursing landowners for ecosystem services with this lens, or does it feel like something where in order to have control around the site, it's more of a land acquisition program?
I think either of those are options. And I think there are certain places probably where acquisition might be off the table. I mean, there might be parts, especially maybe in more agricultural areas, where people would not want to necessarily sell their land to the government, but they might be willing to do like what you say, sort of a fee for service. Okay, we're going to basically lease your floodplain, landscape essentially for beaver to be there. We're going to make payments to you the same way we'd make payments to you if you had cover crops or something like that on that. So I think there are probably a variety of different avenues, but I think that we need to be thinking along those lines in terms of compensation, because I'll go back to this example, which is the Annapolis Roads example. So here we've actually got two different landowners. The pond is primarily on the land of a gentleman who lives over here. Basically, it's kind of out of sight, out of mind for him, but he likes it as a natural feature. This gentleman is concerned that the pond's going to go into his basement, that he's adjacent to it, even though the pond's not on his property. And so the pond leveler here was kind of an elegant solution where both landowners were okay with the pond being there as long as there was some kind of control for the sort of expansion of the pond. But I don't know that that's the norm. You probably are going to encounter situations where some landowners are just going to object out of hand. Some people may be sort of neutral, and some people may be on board until things get a little bit hairy in terms of what the Beaver decides to do. So I do think the assignment of economic value to these features makes that leap to what you're talking about much easier. So if I know, well, this is $1 million, an equivalent of $1 million feature essentially in terms of the county's regulatory compliance, it's an easy case for me to make to go to the county council and say, we could buy that area for $15,000 and then it's ours, and we don't have to worry about the neighbors getting upset about it essentially. Or we can make this, payment for services essentially. So I think it's a key piece to make that next step, which is going to be a necessary tool in our toolbox if we're going to do this on a broad scale.
Erik, thank you so much
Sure.
for talking more about the compensation and crediting.